All right, so today we're going to talk about, we're looking at our solving right triangles still, and today we're going to look at seeing some of the real situations where we can see those applied to some situations in life. So we're going to have two things that we're going to talk about. We'll talk about angle of elevation and angle of depression. So when we're talking about depression here, we're not talking about moons or anything like that. We're talking about the angle. So angle of elevation would be like if I'm here on the ground and I'm looking up at something. So the angle that is made with me looking straight out to looking up, this angle is your angle of elevation because I'm looking up. If I am on top of something, so say, then I'm looking up at this person here, or this object here, then the angle of depression would be the angle formed with that person looking straight out and down compared to down at me. So this here is your angle of depression. So, since these are parallel lines, this horizontal line here, that makes the angle of depression and the angle of elevation alternate interior, and alternate interior angles are equal. So, angle of depression equals the angle of elevation. The key is that we want to make sure, a lot of times if they say the angle of depression is 30, we want to put the angle of depression here, but it's not that one, it's this one outside here, but the complementary to it would be the angle that's inside. All right, so let's look at a couple here. At the circus, a person in the audience at ground level watches the high wire routine. A 5'6" tall acrobat is standing on a platform that is 20 feet off the ground. How far is the audience member from the base of the platform? So we want to know the distance from the person to the base. So that's why our X is there. If the angle of elevation, so the angle between him looking straight at the base to him looking at the top of the acrobat's head is 27 degrees. So when I'm looking at these, I want to make sure I think of all the important things that I'm looking for. And I know I'm looking for distance because of that how far. And then I want to make sure I have all of these numbers also in there. So since I'm looking at the top of their head, or the audience member's looking at the top of the head, we're going to do the 25 plus the 5.5 because it's 6 inches would be half a foot. So this whole side is actually 30.5. And that angle, again, is 27 here, and then we're looking for X. So if we don't draw it out, it's really hard to know how we're going to set it up. If it's drawn out and then drawn out correctly, the setting up part tends to be just like what we've been doing. So we would look at how 30.5 relates to 27, that's opposite, and X is adjacent. So we have our so opposite and adjacent go with tangent. So I'm going to set up my expression, tangent or equation 27, so tangent of your angle equals a ratio, and that ratio, we know part of it, but it's opposite, so 30.5 over X, and we don't know what X is. So this equals a decimal that's could be written as a ratio, and we want to know what that X would be to make that ratio the same. So we multiply both sides by X. So I get tangent, or X tangent 27 equals 30.5, and then divide by tangent 27. So those will cancel out, and I take 30.5 divided by tangent 27, which is 59.859, so 59.9 feet away from the person. So mostly the hardest part is setting these up and drawing that out and making sure we have that drawn correctly. Okay, let's look at another one. We're at a diving competition now. 6-foot tall diver stands on top of a 32-foot platform. The front edge of the platform projects 5 feet beyond the pool. So we have our pool, and here's the edge. And they are on top of a platform diving board that's 32 feet up. They are 6 feet. And they are out 5 feet here. And the pool is 50 feet. So this is 5 feet into the pool. So we're looking for, we have this 32 plus 6. So this is total of 38 feet up. And we want to know, a camera is set up at the opposite end of the pool, even with the pool edge. If the camera is angled, we want to angle the camera so that you can see on top of the head of the diver. What does that angle have to be? So we're looking for this angle here. So again, once I draw it, it's a little bit easier. So we're 5 feet in, so this total distance was 50, so this distance on this is 45. So we want to find an angle. Remember, when we're looking for angles, we use those inverse because we have tangent, again, because this is opposite and adjacent. So tangent of my angle, x, which I don't know, is opposite over 45. But if I take the inverse and do tangent -1, that will give me that angle that has this ratio 38 over 45. So I get 40.2 degrees, or 40 degrees approximately, to the nearest degree. Okay, let's look at some with the angle of depression. So Maria's on top of a cliff, and they have it drawn here. It sees a seal in the water. The cliff is 40 feet above the water, and the angle of depression is 52. So that means that the angle of elevation is also 52, as those, remember, are equal. How far is the seal to the cliff? So we're looking for x here. So again, we have opposite and adjacent. So we're going to set up our tangent. 52 equals 40 over x. X equals 40 tangent 52 divided by tangent 52. X equals 31.3 feet.